When something massive is about to break in the cybersecurity world, Unit 42 is usually already paying attention to it. My name is Caden, and today we're going to talk about a critical vulnerability that showed up right at the core of modern web development, specifically React server components and Next.js. This critical flaw allowed for remote code execution, required no authentication, and worked straight out of the box on default configurations. Did I mention that this vulnerability also earned itself a CVSS score of 10? Which is the highest severity rating we use when measuring criticality? React is a client-server Java-based framework that revolutionized the usually slow, network-heavy interaction by building the Flight Protocol. For years, web apps used to be split cleanly down the middle. The browser purely handled all the clicks and visuals, and the server handled all the logic. So every interaction meant sending that request, waiting, and often an entire reload of the page. It wasn't fast, but it worked. And to be clear, teams didn't move into this React direction blindly. React took off because it genuinely fixed a lot of the pain points that developers were dealing with. Front-end teams that wanted interfaces that felt instant and smooth user experience. React is what made it possible. With frameworks like Next.js, running React on the server was easier and more accessible. Before long, this became the default way that modern web apps were built. To make that kind of experience possible at scale, though, React had to evolve a bit. That evolution came with React server components. Instead of forcing developers to make the browser and server work together manually, React handled that connection for them. When everything is working as intended, it's fast, efficient, and fantastic for modern web applications. For what we gained in efficiency, we also lost a little bit in security. See, these flight requests aren't treated like random internet traffic. React assumes that these requests are coming from code that it generated itself, so the server lets its guard down a little bit. And that trust works great, right up until it doesn't, because once browser-driven code starts executing on the server, a small mistake doesn't just affect the page anymore, it affects the system behind it. And that's exactly the door attackers were waiting to walk through. Researchers had found out that an attacker could send a very specially crafted flight request that the server fails to properly validate the contents of. They had remote code execution. There wasn't an authentication check to bypass here. The server simply trusted the request based on how it looked, not necessarily who sent it. That distinction is important because this isn't about stealing credentials, but rather abusing something that exists within how React functions. So, once the request was accepted, the server ran whatever code came with it. And here's another thing. This exploit works every time. If the server is unpatched and it gets a malicious request, it's gonna run the code. So how exactly did attackers exploit this vulnerability? They had found a way to slip extra instructions, like I mentioned earlier, into those trusted requests through a technique called prototype pollution. In JavaScript, both in browser and web server, because of the object-oriented nature of the language, many objects share common behaviors under the hood. So, when attackers are able to tamper with the shared behavior, their code doesn't just run once, it runs everywhere that behavior is used in other applications. That is how a single request turned into unrestricted code execution across the whole server, and ultimately, full control. The unchecked flight request allowed an overwrite of these object templates on the server. Now combine that with how widely React and Next.js are used. React alone accounts for roughly 40% of developers, and Next.js is one of the most common ways that teams can run React on the server. Just looking at the numbers in our own ASM product, Cortex Expanse already identified hundreds of thousands of companies being publicly exposed across the internet. And now, here's the thing. There are many potential routes to go down with a crazy vulnerability like this. Let me share how our Unit 42 folks found a way to handle it. Our managed threat hunters began analyzing how this exploit could be abused in live environments. From figuring out how these React server components were being implemented, how the flight requests were being used maliciously, and what attacker behavior would look like after doing such a thing, Unit 42 left no stone unturned. So, how can we even confirm if an application is exploited? Well, as part of their response, Unit 42 used something called XQL hunting queries. If you're not familiar, this essentially functions as a way to search for the same abnormal behaviors across all environments. They first focus on what an attacker would likely do after getting code execution. Let's call these the symptoms. One set of queries was one where Node.js servers were executing system-level commands and interacting with files that normally wouldn't be touched. For example, a PowerShell command issued by the Node or Next.js web server, or accessing credential files, SSH keys, and other sensitive system information that's usually off-limits. There were even queries that allowed them to get things like what user account is currently being ran on the server, what network that they were currently on, as well as check if there's anything else valuable sitting on the machine. By running these queries, Unit 42 is able to spot environments where breaches might have occurred and step in to thwart it. This turns threat intelligence into a fast impact assessment, which is crucial to know if attackers are already in doing their things and need to be kicked out before the ransom note comes. In terms of how this issue gets resolved, the only true fix is a patch. If your environment is running a vulnerable version of React or Next.js, you simply need to upgrade it, as well as rebuilding and deploying all your apps with the new libraries. Full stop. But while teams are hastily patching these systems, that doesn't mean that your defenses should just drop off the face of the earth. Cortex XDR and XSIAM play a crucial role in helping keep these defenses sharp. Behavioral signals now prevent execution on those unusual things that Unit 42 were looking for to assess damages. And this happens in real time, monitoring the Node.js web server process itself. So, in a case like this, if a vulnerable server suddenly starts executing bizarre commands or spawning shells, Cortex XDR's behavior threat protection and BIOCs can step in to block that activity outright. That kind of layered protection matters. Would you rather be aware and biting your nails knowing that a vulnerability exists and could impact you, or would you rather be ready for it? My name is Caden, and thanks for watching. Stay safe, stay secure, and I'll see you in the next one.